So we're going to move on to the focus demo by Oleg Smirnov. It's going to be about Radio Padre.
So in the POC this year, there was some grumbling that a large fraction of the submissions started with the phrase about the coming deluge of data in astronomy. And I think we were even threatening to introduce machine learning algorithms to deal with this. So I thought I would immediately take countermeasures. And if I'm going to talk about the deluge of data, then I might as well talk about it in Old Testament terms. To defeat your machine learning algorithms, and I call it my GAN, Googling about Noah. Chair, can I have a canned audience laugh track, please, at this point? Anyway, I don't actually want to talk about the deluge of data. What I want to talk about is how it has changed our working habits and what I'm trying to do about it. There's a picture here which I borrowed from my colleague Bill Cotton, who is also a rather Old Testament character. I think this picture has been up on his webpage since the first Clinton administration. And some of the people in this webinar are probably too young to recognize what it is on the picture. I think that's a DAT tape, right? We used to have that when we thought we had big data. So it's 3 a.m. Do you know where your data is? Well, I know where my data is. It's not with me, right? And we've gone through this process recently. We used to be very attached to our data. It was actually a reasonable thing to process data on our laptop, on our workstation. And now, well, I've come to terms to the fact that I'm separated from my data, which is really, on the whole, better for both of us, because data gets to hang out at the data center with other data, right? And I'm free to have a sleek and light laptop, which used to be great for traveling. Now I just get to sit at home and stare at it. But anyway, I think both me and data are happier with this. Some people still cling to their data. And in the days when we all traveled, you could recognize them. They had these big laptops with wheels attached, so that they could carry their big laptops around. And in the post-COVID era, I'm not sure how to recognize these people now. They're a bit of a dying breed. I suspect it's the people who keep their Zoom video link off because they're forced to reduce data in their underwear on account of the laptops being so hot. Anyway, for us, it's not an option. Meerkat produces 1 terabyte every 8 hours in the economical data regime, right? And 8 terabytes at full resolution. So it's completely impractical to keep the data on the laptop. Data has to be somewhere far away. And that means it's a bit of a regression to the past for us, right? Because we used to have data close, we could analyze it with GUIs, with tools. And now I'd like you to tell me, or tell me later, if you recognize yourself in any of this. So this would be my situation if ADAS was properly physical. I'd be sitting in my hotel room in Granada. Now I'm sitting in lockdown at home. I'd be on a crappy hotel Wi-Fi. And my data in my pipeline is safe. It's back in South Africa, but it's far away, far away. My pipeline run has finished. Maybe it's crashed. I got to diagnose that. I've got 300 log files, 200 plots, 50 FITS images, and a dozen HTML reports to deal with. And I don't know who I picked up this phrase from, but I like the quote that debugging is like playing the detective in a crime movie, except you're also the perpetrator and the victim. Well, when your data is remote on some computing cluster, then every debugging session is a post-mortem. So what I need to do is I need to make sense of the mess that my pipeline has made so I can diagnose things, change things, and start another run. But maybe my bandwidth is not so good. Certainly there's going to be network lag. Almost quite often, if you're not running your own cluster, or if you're not very good friends with the cluster administrator, then the software stack on the remote end is not going to have the stuff you need, right? It's not going to have your favorite FITS viewer. And anyway, you wouldn't be able to use your FITS viewer because of the network lag. So what we've done traditionally, like even up to a year or 2 years ago, in this situation, I would start an rsync session overnight to get some data products onto my laptop, pray, and then with the internet's blessing, maybe in the morning I've got downloaded enough stuff that I can look at it and diagnose something, and then maybe run my pipeline again. So Radiopadre is meant to address that. If you were in the BOF session earlier by Jan Nordum, he spoke a lot about users and developers. I don't think those are two separate categories. I think it's a whole spectrum. And we are all on the spectrum. At least that's what my girlfriend tells me. But I think it's actually useful to think in terms, not of developers, of users. It helps to think in terms of the caps we're wearing when we interact with our data, when we interact with our pipelines. And the first cap is what I call the power plumber. I'm sure many of you are familiar with this situation, right? You arrive at the scene, your pipeline has crashed, there is raw sewage dripping from the ceiling, God knows what happened. You've got no idea. You just have to roll up your sleeves, plunge in, and figure out what the hell went wrong, right? That's kind of the first cap. The second cap is what I call the Chernobyl operator. That's when your pipeline works reasonably well most of the time and things run smoothly, but every now and then there's a catastrophic meltdown. So you kind of have to, you want to be able to see everything continuously all of the time. So you've got this enormously elaborate visualization requirements. And then the third cap, that's the button pushing astronomer. And for the button pushing astronomer, of course, as a button pushing astronomer, which I strive to be, you want things to be as easy as possible. So quoting Einstein and my colleague Tony Willis, everything should be made as simple as possible, but not simpler. And Tony had some great words about the ideal user interface. So anyway, in a situation when your data in your pipeline sits remotely, then what tools do you have available to play these roles? The plumber and the operator will probably be using the shell, which is available everywhere, but it's not terribly productive. If you're lucky, you've got a VNC installation on the remote cluster. Maybe you can start a remote desktop. Maybe you can view some images. Once you've put a lot of effort in, you might have a bespoke GUI, or you might have a web interface, or your pipeline might produce HTML reports. That's sort of the solutions I'm aware of for this remote data problem. And what I suggest is that Radiopadre kind of addresses all of these roles in a rather simple way. So I think at this point, I should just start the demo. We'll wear our first hat one first, that of the power plumber. So basically, we're trying to troubleshoot the scene of the crime, which means we just want to plunge in and poke around. And I think you see my terminal now. Just to give you a taste for it, if I log into a machine where I'm conducting the demo, and I've prepared a little directory here, and you can see it's a mess of files, it's a mess of plots, and how do we make sense of that remotely? The machine I'm logging into is at the moment 1,000 kilometers away, so the connection is not too bad, but still. So what I'm going to do, this is now running on my laptop, Miles. What I'm going to do is I'm going to run Radiopadre, telling it to connect to a machine named Simon and go to this directory. And you can see it's established an SSH connection and popped up a browser. Now, the browser is running locally on my laptop. On the remote end, there is now a Jupyter server. There's something called Carta, which I'll get to later. So concentrate on the Jupyter server for a second there. And we can open notebooks, right? So let's open up a notebook. And you can see the notebook has just one command on it. It says from Radiopadre import ls. And ls is just basically, it's the only command actually you need to know in Radiopadre. And it means the same thing the Unix ls command means. It means list files, right? So if I execute this code cell, nothing happens. It's just an import statement. If I do an ls, I get a nice file listing. And I imagine most of you know how Jupyter notebooks work, right? There is Python code that I'm editing locally in the browser. This gets executed on the remote end, and the results get displayed back in my browser. And if the results produce HTML, then the output is rich, as it is here. So this looks just like a fancy directory listing. It is essentially just a fancy directory listing. What we can do is we can say, let's take this directory listing and let's take the first element. And the type of this object is something called the data dir. And the data dir works just like a list. So first of all, we can display it. So now we're displaying a subdirectory. And secondly, because it's a list, we can do all the usual list-like operations with it. We can take the first 10 elements, for example. We can take, let's say we take element number 28. And element number 28 happens to be a text file. And you can see when you display that text file in console, what you get is an HTML output of the file. We can do all sorts of familiar things you would do with text files. You can display the head, you can display the tail. Another interesting thing you can do is the function call operator works with the same semantics as grep. So this says, I want to search for all lines containing info in this file, and you get them as the output, right? And the type of this object is also a type of why does my clipboard not work? It really doesn't really want to work. So that's a text file, and the type of something that has search a text file is a numbered line list, right? So that's text files. Now let's look at something more interesting. If we look at something like, well, let's remember DD is our data directory. We display our data directory, and we see it's got a subdirectory number 4, diagnostic plots. Let's look inside there. And we see it has another subdirectory called crosscall. Let's look inside there. And we see a listing with a bunch of PNG files and a bunch of HTML files. Every one of these file names is clickable. So if I click on it, I get the web server to serve me the actual image. But I can actually do something even more interesting than just look at the directory listing. I can say, okay, give me all the PNG files in this directory. You can see the function call operator again has search semantics. And now that I have a list of PNG files, well, I want to show them as thumbnails. And I get all the 30 plots that were sitting in the subdirectory as a nice thumbnail display. And every one of them is clickable, pops up the plot in a separate browser tab. So that's all very nice for managing plots that your pipeline produces. Now going on to the next one. And these things are collapsible if you click here. So you can unclutter your display by collapsing the thumbnails. Going on, let's look again at our directory. You can see I've got a couple of fits files in here. So what I'm going to do is I'm going to say again, I can filter out the fits files a little bit by file name. And then I'd like to take file number 1. So I say, I take a variable ff equals fits file number 1. And now I have an object that's recognized as fits file. And you can probably guess that there's many wonderful things you can do with fits files in here. Well, for starters, you can look at their headers. Now, a header is just a bunch of text lines, so it will actually have the same semantics as a text file. For example, you can search through it just like this if you want to look at all the history entries of the header. But even better, even more relevant for fits files, what you can do is you can well, you can just show the fits file. If I say ff, something buzzes along, and what you see a little thumbnail rendering of the fits file. This one is, I'm going to saturate it a little bit. And zoom into it. So you get a nice, beautiful display of this radio galaxy, right? And these things are just optional arguments to the show method. Every object has a show method, which forces the object to be displayed as HTML. Keyword arguments modify the display. And it's also possible to actually set these things globally. There's something called the settings objects. And if I look at settings, they're also rendered in HTML. And I've got settings for fits files. And what I can do is I can set the rendering settings globally. And this will have the same effect as passing them in through keywords. So another very neat things about fits files, you can see both here in the corner of the display and up here where we were showing them as a directory list, you've got these buttons labeled JS9 and C. And what they will do, they will actually open a fits viewer for you. And there are two web-based fits viewers that are bundled with Radiopadre. One of them is called Carta. And neither of these is my work, right? I'm just bundling them along with Radiopadre and they get installed. So Carta is an online fits viewer. It gives you, well, the fits image resides on the remote server, right? And all that gets shipped to my laptop are little PNG tiles to display this image. So this is nice and functional and slick and uses some very modern web technology. There's another viewer called JS9, which people are going to find probably familiar because it's written by Eric Mandel, who is also behind GS9. So it has a very GS9-like interface. Very different flavor from Carta, but also extremely powerful. I mean, you can do even stuff like, I don't know, 3D plots. I mean, oops. I mean, isn't this wonderful? This is running in my browser, right? And it's a fits viewer with a three-dimensional plot. And you get that pretty much for free with Radiopadre, right? You just click the appropriate button next to the fits image in the file listing. There's some more stuff to see. There are specific things for radio astronomy. For example, if I look in the first subdirectory here called cal tables, I'm going to see a bunch of files which are what we call CASA tables. So I'm going to say, let's say, table is subdirectory 1, file number 7. And that's an object called the CASA table. And CASA tables are the standard format we use to store data in radio astronomy. So this particular table stores calibration solutions. And what a table is, it's kind of a lightweight relational database. So it's got rows, it's got columns. And if I display it, if I tell Radiopadre to display it, I just get a display of probably the first 100 rows in this table. The table is massive, so it's not going to display the whole thing. And of course, a table is just like a list. So if I want to display particular rows from a table, I can give a slice. This displays the first 10 rows. And I can even do things like queries. There's a query language implemented in CASA tables, which is accessible here through the function call operator. So for example, this looks up all rows in the table where the value of column antenna 1 is 1. You get this nice little output. And this, of course, is a list-like object. So if we can take the first 4 rows of that, we get this. And finally, I imagine you're catching on to the fact that every file on your remote file system corresponds to an object in Radiopadre, and every object knows how to display itself. So you can actually ask all the objects to display themselves as thumbnails. And now you kind of get a mix of some objects don't know how to render themselves as a thumbnail very well, but other things like fits files, PNG files, they know perfectly well how to render themselves into a thumbnail and give you this nice little display. And this is, of course, clickable again, right? You click on any thumbnail, you get the full plot in a separate browser tab. So that's it for Plumber mode, right? You can kind of quickly and interactively get an idea of everything that's happening on the remote end. A few words about what's happening under the hood. So this is your remote cluster. This is your pipeline. It's producing data products. This is your laptop. This is your SSH connection. The only thing you need to run this is an SSH connection, nothing else. If you have SSH connection to the remote end, that's it. What happens on the remote end, it starts a Docker or a Singularity container or a virtual environment. Inside that container, you've got your Jupyter server and you've got all the various processes required. There's a web server for Carta. There's a helper process for JS9. And this is what's rendering your data products. These things, of course, they expose ports, which Docker or Singularity exposes on the remote end. And these things are port forwarded through SSH into ports on your local laptop. And you're running a browser. There's a JavaScript virtual machine in the browser. And in the JavaScript virtual machine, you're running the JS9 GUI or the Carta GUI. And this talks to the ports forwarded to over SSH. The result is hopefully a happy user. This thing is practically zero admin. The only thing you need on the client side is Python, SSH in the browser. And on the server side, you need either Python with Docker or Singularity. And then it downloads containers of Docker Hub and runs Radiopadre in a container image. And that's kind of guaranteed to work anywhere. Or the more lightweight version, if you've got Python 3.6 and virtual env, you can run Radiopadre in virtual environment mode. That's kind of more lightweight than a container, but not completely guaranteed to work on every system, right? Because as you know, in a virtual env, you depend on the native libraries. I'm giving you a link, but you should be able to just Google for this. And in principle, this thing should be remote installable by the user on a naked server without root privileges. So I can show you, I've got another machine called Garfunkel, and this one doesn't have Radiopadre installed. So when I run Radiopadre locally, it tells me, okay, there's an error, try rerunning without the init. And if I do that, you can see it goes off and creates a virtual environment on Garfunkel and starts installing. And that's going to be a bit of a story. I don't have enough time in the demo to wait for the installation to finish, so I'm going to interrupt it. I'm going to go on to the next subject, which is our second head, the Chernobyl operator. And radio interferometry is a good example of this, right? Because in radio interferometry, we have a very long path from raw data to our science radio data products.
Oleg, I'm sorry to interrupt. You have like 5-6 minutes left.
Yeah, I'm keeping an eye on that. So I'll do a quick demo of this and then I'll stop. So we have a very long pipeline which goes through many stages, and lots of things can fail along the way and fail in very non-intuitive ways. So it's absolutely essential to have intermediate diagnostic products if you're going to figure out what went wrong. And if you've got a mature package or a mature pipeline, then you know your likely failure modes. So you can, you can get a postdoc or a PhD student to write some code that will render a neat HTML report and show you all the things that you need to see. But if you've got an immature package, then you don't really have a choice. You need to leave all the guts hanging out, because when it inevitably crashes, you want as many clues as possible for your postmortem. And this is kind of what I call the death by information syndrome, or the Chernobyl control panel syndrome, because yeah, you can make 400 plots, but what's the point of making 400 plots if you can't, make sense of them, especially when you're talking to the cluster over the network and you've got network latency and all that. So in my remaining 4 minutes, I'm going to show you that it's actually very simple to make Chernobyl control panels with Radiopadre. You can probably make one in 4 minutes. I'll use the Caracal pipeline, which you can see in a poster by Josh in this conference as an example. So let's see if I interrupt this connection. Again, I'm connecting to a machine called Simon, and I'm going to directory called projects. And that loads up a little, very simple notebook I've made, which you can see it just does an ls and lists IPython notebooks in subdirectories. So if I run this thing, this is kind of a very convenient starting off page for me, because it shows all the things I'm actively working on, including this project, which you can see has had a lot of trial and error. But I want to take you to this notebook here, add as demo, standard progress report. And So here is a notebook. You can see the notebook is actually very minimal. It only has a few code cells. And if you look closely at what's being done in these code cells, again, all I'm doing is I'm calling the ls function and asking for thumbnails, essentially, not much more than that. And I'm basically here, I'm relying on the fact that when the pipeline runs, the pipeline follows certain naming conventions for the directories and for the files that it produces. So just by specifying specific file name patterns, I can match those up to products that I want to display. So if I run this notebook, what I get is, well, here's some preachy stuff at the beginning. Then I get all my log files here, arranged most recent to least recent. Here I get all the diagnostic plots that the pipeline has produced. They are nicely collapsed because otherwise I would be completely overwhelmed by them. And in fact, I think my browser is overwhelmed by them because I'm trying to uncollapse them and I don't see anything. And also I can hear my fan going, so this will teach me to run this on a thin and light laptop. Anyway, I can see I'm about to run out of time. And as you know, the first rule of live demos is never to do live demos. So I think this might be a good time to stop. I'll try to reload this, maybe it will display. And in the meantime, I'll take questions if you have any.
Thank you, Oleg. Yes, there is one question. Can you take values out of the fits image or CASA table rows and do, for example, computations?
No, of course, right? Because this is a standard Python notebook with just some extra functionality on top. So you can have cells that do whatever Python you like, right? It's that's the beauty of it. You're talking to a Python interpreter on the remote end. You can import AstroPy, you can import matplotlib, and you can do basically whatever you want with it.
So you have full access to those files.
Yeah, completely full access to those files, right? It's a Jupyter notebook, so it can do anything a notebook can do, anything that Python interpreter can do.
Thank you very much. That was a great demo. It sure piqued my interest. I have a few notes. And
Thank you.
thank you. And let's run the applause.